Welcome back to AI.Code.Cast. Ready for another deep dive into a classic coding challenge?
Absolutely. Always up for a challenge.
Today we're going to tackle sorting characters by frequency.
Ooh, that's a good one. Sounds simple enough on the surface.
But there's some sneaky complexity lurking under the hood.
Right, yeah, especially when you start thinking about efficiency,
Yeah,
especially for those super long strings.
exactly. Like imagine trying to sort the characters in, say, an entire book.
Yeah, that could get messy quickly if you're not careful.
Okay, so let's break down the problem itself first. You're given a string, right?
Right.
And the goal is to rearrange the letters so the most frequent character comes first.
Okay, so like if we had the string, let's say tree,
Okay, tree.
the E appears twice, right?
Right.
So it would come before the T and the R, which only appear once.
Got it. So let's say our string is banana.
Banana, classic.
A simple approach,
Yeah.
just thinking off the top of my head,
Yeah.
might be to just go through the string, count how many times each character appears, and then kind of sort them based on those counts.
Yeah, that's a natural first thought, right? Just like, okay, let's count everything up and see what we've got.
Yeah.
But there's a potential hiccup there.
Oh, I see what you're getting at. The efficiency thing.
Yeah. It's all about how a computer would actually go about doing that. It ends up involving a whole bunch of comparisons, right?
Right.
Like for every character, you'd have to check it against every other character.
Oh, so as the string grows, the number of those comparisons just blows up.
Exactly. It gets slow really fast.
So we need something a bit smarter. Something that can handle a massive text file without taking like a week to run.
Precisely. And that's where those clever algorithms come in.
Right. What if we try to, organize the characters and their counts in a more structured way?
Interesting. Instead of just comparing everything directly, what if we use a tool designed for storing and accessing key value pairs super quickly?
Are you talking about a hash map
You got it.
where the character is the key and its frequency is the value?
Exactly. Think of it like a digital tally sheet, keeping track of how many times each character shows up.
Yeah, okay. I like that. So that would definitely streamline that counting process.
For sure.
But then we still need to sort them, right? Sort those characters by their frequency from the hash map.
You're absolutely right. We've got the counts. Now we need to put them in order.
And I bet there are a bunch of different ways to tackle the sorting part.
Oh, yeah, definitely. A bunch of different paths we could go down.
So where should we start? What are some of the common approaches?
We could start with those classic sorting algorithms like merge sort or quick sort. Where,
Sure, those are the kind of go-tos for general sorting.
yeah, but they typically have what we call a time complexity of O(n) log n.
Okay, so better than the brute force approach, but still maybe not ideal for massive data sets, right?
Right. Plus, those algorithms aren't specifically designed for sorting by frequency from a hash map. They're more general purpose.
So we need something a bit more tailored, something that leverages that structure we've already created.
What if we grouped the characters based on their frequency?
Interesting. So all the characters with the same frequency, they'd end up together.
Exactly. But then the question is, how do we group them efficiently?
Right. Because it feels like we'd still be doing tons of comparisons.
Okay, here's a thought. Instead of comparing, what if we directly use the frequency as an index?
An index.
Yeah, kind of like assigning each character to a labeled box based on its frequency.
Wait, you're talking about bucket sort, aren't you?
You got it?
That's like the mail sorting analogy, right? Each zip code has its own bin, and we just chuck the mail in.
Exactly. We're basically doing the same thing here. Each frequency gets its own bucket. Then, to get the sorted string, we just go through the buckets in order.
Oh, that's brilliant. We're not comparing characters directly anymore, just strategically putting them in the right bucket. And I remember we said bucket sort has a fantastic time complexity.
It does. ON, linear time complexity. Super speedy, especially for large inputs.
Amazing. Okay, so we've talked about hash maps with a custom sorting function, and now this bucket sort approach. But didn't you mention some Python-specific solutions too? Something with counter and OrderedDict?
Oh, yeah. Python has some really cool built-in tools that can streamline this whole process. Want to dig into those?
Absolutely. Let's see what Python has up its sleeve.
Let's dive into the Python magic then. So first up, we've got the counter object. It's made for this kind of problem.
Yeah, you mentioned that it handles the counting part,
Yep.
automatically.
You just give it a string and boom, it gives you back this dictionary-like object where each key is a character and the value is how many times it appears.
So we can skip writing that whole counting loop we would normally need with a regular dictionary.
You got it. Counter does all that work for you. And it even gets better. It's got this method called most common.
Most con.
Yeah, and what that does is it gives you back a list of the characters and their counts, but they're already sorted by frequency, highest to lowest.
No way. So counter handles both the counting and the sorting, like all in one go.
Yep, it's a real time saver.
Okay, I'm sold on counter. But what about OrderedDict? Where does that fit in?
Ah, that's where things get a little more nuanced. See, sometimes you care about the order of characters that have the same frequency.
Oh, right. Like in our tree example, both E and tin appear twice.
Exactly. If we just use a regular dictionary or even counter, we might lose track of which E came first in the original string.
So we might end up with, like, eat instead of tree.
Yep, that's where OrderedDict shines. It remembers the order in which you added things, so it helps maintain that stability in your sorted string.
Okay, I get it. It's like if we care about preserving the original relative order of those same frequency characters, OrderedDict is our friend.
Exactly. It gives you that extra control over the sorting process.
So we've got options. A super streamlined approach with just counter if we don't care about the order of those same frequency characters.
Right.
Or we can bring in OrderedDict if we need that extra precision.
Exactly. Python's got you covered either way.
This is awesome. Python really does have a way of, like, making things elegant, you know?
Oh, for sure. And it's not just about elegance, it's also about efficiency. When you use the right tools, you can really boost the performance of your code.
Right. Like we saw that with bucket sort, too.
Yeah.
Sometimes the way you structure your data can make all the difference in the world.
Absolutely. Choosing the right data structure is like half the battle sometimes.
Okay, so we've explored a bunch of different approaches here. Everything from that initial kind of brute force idea
Hmm.
to hash maps to bucket sort, and now these cool Python tools.
Yeah, quite the journey.
And I think what's really cool is how each approach has its own strengths and weaknesses.
Totally agree. It's not about finding the one best solution. It's about understanding the nuances of each approach and picking the right one for the job.
So it's all about, like, balancing those trade-offs, performance, readability, using the right tools for the language you're working with.
Yeah, exactly. It's that whole idea of choosing the right tool for the job. Sometimes a simpler approach might be more than enough, depending on what you're trying to achieve.
That's true. It can be tempting to always reach for the most sophisticated solution, but sometimes it's overkill.
Yeah, sometimes the straightforward approach is the best. And sometimes diving into those different approaches can even spark new ideas, you know?
I totally agree. It's all about that exploration and, like, pushing yourself to think about problems in different ways.
Couldn't have said it better myself. So we've covered a ton of ground today. What stands out to you? Any favorite approaches or takeaways? Lots of great stuff. But I think what really hit home for me is how understanding the problem can lead to some super elegant solutions.
Mhm.
Like with bucket sort, knowing that maximum frequency can't exceed the length of the string was key, right?
Totally. That constraint let us create that fixed number of buckets, which made the whole sorting process so much faster.
Yeah, it's like once you see those constraints clearly, the solution can just click into place.
I totally get that. Okay, so before we wrap up, any final thoughts for our listeners out there who might be tackling this problem themselves?
Let's see. I'd say don't be afraid to experiment. Try out different approaches, play around with different data structures, see what works best for you.
That's great advice. And remember, there's no one right way to solve a coding problem. It's all about finding the most efficient, readable, and maintainable solution for your specific needs.
Exactly. And hey, if you come up with a cool solution, share it with the AI.Code.Cast community. We're always up for learning from each other.
Absolutely. We'd love seeing all the creative ways people are solving these challenges. So that's it for this deep dive into sorting characters by frequency. Big thanks to our expert for joining us today.
Thanks for having me. Always fun to geek out about code with you.
And to all our listeners, keep coding, keep experimenting, and keep those algorithms humming. Until next time, happy coding.